All right, hello everyone. This is lesson 6, exponential regression continued. So we're still going to be graphing things. So if you want the introduction on how to do regression, that's the last video, and this is lesson 6. All right, so we have this first question. A box containing 1,000 coins is shaken, and the coins are emptied onto a table. Only the coins that land heads up are returned to the box, blah, 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 blah. So we have this situation. We're going to put this in as L1 and L2. Okay, so go to Stat and Edit. And in L1, you're going to type in your values. So 0, 1, 3, 4, and 6. And in L2, we're going to put in 1,000, and 602, and 217, 130, and 47. All right, now we need to calculate our exponential regression. Now, one thing to make sure is we have our diagnostics on. All right, so because this is the app and not the exact thing, you should see where it says diagnostics on and make sure that's good to go. And then you're going to go to Stat, scroll over to Calculate, and you want to go to EXP-REG. All right, so L1, L2. And what we do want to do here is store this as Y1. So hit vars, function, and then Y1. And hit enter. And we get this information here. So our equation is going to be y is equal to 1,000, because we're going to round that to the nearest hundredth. So 1,000.96 multiplied by our b value, so 0.60 to the x. Use your equation from part A to algebraically determine how many coins would be returned after the 8th trial. So that means when x is equal to 8. So we're going to go y is equal to 1,000.96 multiplied by 0.60 to the x. And oh, I missed a 0 there. It should be 1,000.96. So on your calculators, you can go 1,000 multiplied, 1,000.96 multiplied by 0.60 to the exponent 8. And you're going to get 16.81. So our outcome here is y is 16.8, so that's going to be 17 coins if we're rounding that to the nearest coin. Using our equation from part A to algebraically determine which trial 6 coins are returned. So in this case, our y2 is going to equal 6. So we're going to do this algebraically. So 6 is equal to 1,000.96 multiplied by 0.60 to the x. So start by dividing by 1,000.96. Okay, so 6 divided by 1,000.96, and you get this value here, 0.00599 ... is equal to 0.60 to the x. Now if we change this to a logarithm, we're going to get log base 0.60 of that 0.0599 number is going to equal x. And then if we do change of base, you get log of that 0.00599 number divided by log of 0.60 is equal to x. So on our calculators, if we carefully type log, and if you type up, you can actually pull all that decimal value in there. Okay, and we close our brackets. Oops, too many brackets there. There we go. Divided by log of 0.60. So we're going to use our rounded values here to actually do this, and we get 10.01. 10.02, so after 10 trials. Okay. All right, now we are going to do this next one here. A researcher discovered mold growing in a petri dish. When it first observed, the mold covered 3% of the dish's surface. Every 24 hours, the surface of the mold doubles in size as shown in the table below. This is supposed to be 72. Okay, so if it's doubling, we're going to get to 12% and then 24%. So we need to input this information in our calculator. So we're going to go to Stat and then Edit, hit Enter. And we need to clear our lists here, or just type over it. So 0, and then 24, 48, 72. And this one we don't need, so you can hit delete and it'll clear it. Okay. And in the second table, we're going to go 3%, 6%, 12%, 24%. We don't need this one, so whoops. Delete that. All right, so we've got our L1, L2. Go to Stat, go over to Calc. Scroll down to EXP, REG, and it did not pull it up. The app doesn't work as well as the calculators, but there we go. L1, L2, and again, we want to store our equation as y1, so we hit vars. You might have to scroll over to yvars on your calculator, but function y1 and hit enter, and we get this equation here. So we get y is equal to 3 multiplied by 1.029 to the x. And we're going to use this function to algebraically determine the length of time to the nearest tenth of an hour that it will take the petri dish to be completely covered with mold. So that means we want it to get to 100%. And that means y2 is going to equal 100%. Or your y value. So 100 is equal to 3, 1.029 to the x. Again, start by dividing by 3. And then you get 100 over 3 is equal to 1.029 to the x. And we're going to change this to a logarithmic equation. So you're going to get log base 1.029 of 100 divided by 3 is equal to x. And then the change of base, we can do log of 100 divided by 3 divided by log of 1.029 is equal to x. So on your calculators, log of 100 divided by 3 divided by log of 1.029, and we hit enter and we get 123 hours. And I got to try and squish that in here. So x is equal to 123 hours. Okay, let's go to the next page. Coffee is a very popular drink. Miss Moyer hates coffee, which is crazy. What a crazy lady. One day when Liam was trying to suck up, he brought Mrs. Moyer a cup of freshly brewed coffee. She did not want to hurt his feelings, so she recorded the cooling temperatures of it. So L1 is going to be our time, and L2 is all our temperature. Now, these lists here are just a continuation of L1. So you're actually going to have a whole bunch of values to put in here. So stat, edit. Let's start with our L1, and we're going to go 0, then 5, 8, 11, 15, 18, 22, 25, 30, 34, 38, 42, 45, and 50. Enter. And we need to go over. Make sure you start at the top. And 179.5, 168.7, and so on. 149.2. Oops. I think I missed something here. Yep, totally messed up the second one. Let's try that again. 168.7, enter. There we go. 158.1, enter. If I were you, I'd probably just skip ahead on the video here. I'm not good enough video editor to trim this part out so it'll magically just show up. But hopefully you're also typing in this stuff so you can practice putting it into your calculator. Oops, I missed a decimal point there. Okay, 105.7, almost there. 102.2, and lastly 100.5. Okay, so we got all our stuff entered, so then we're going to hit Stat, scroll over to Calc, go down to EXP, REG, and again it didn't pick it up for some reason. Okay, and store it as y1, so function y1, and there's our information. So our regression equation, we need to round each one to the nearest 1,000, so it's going to be y equals 171.462, and our b value is 0.988 to the x. So based on the equation that we got, what was the initial temperature? Well, the equation gives us that the initial temperature is 171.462 degrees. However, we know that it's not to be true, but recall that a regression equation is just a line of best fit. It's just trying to plot it correctly. And there's lots of factors that go into something cooling down, like maybe a window was open for a couple of the minutes, or maybe the heater kicked in so it didn't cool as quickly. So we know that the actual initial temperature was 179.5 or 180 degrees, but our equation comes out as 171.462. What is the predicted temperature of coffee after 1 hour? Well, note that our points are in minutes, so we need to do 1 hour is equal to 60 minutes. So that's a x value. So if we go to our y equals, you should see that it is stored in y1, okay? And if we go to our window settings, our x max should probably go to more than 60 minutes, okay? Let's do 75 minutes, okay? And our y max better start at least 180, so let's maybe go to 200. And let's see what that looks like. Okay, that looks pretty good. And now we want to calculate when x is equal to 60, or 60 minutes. So hit the second button, and then calc, and it says value, and then hit 60. Hit enter, and it shows 84.35 degrees. So for this one, calc value, and we get a y value of 84.35 degrees. When is the coffee at a temperature of 106 degrees Fahrenheit? Well, our degrees Fahrenheit are y values. So here we are going to set y2 equal to 106. So under y equals y2, we go to 106 and graph it, and you should see a line. And we want to get this intersection point. So second trace gets us to the calc. And we're going to intersect, hit enter, left boundary. We just want to get close here. So to the left of the intersection, yours it'll say first line, second line. So right boundary, on my app, it's going to say find the intersection. And here we get the intersection of x is equal to 40.67. So x is equal to 40.67. So after 41 minutes. 41 hours, I'm pretty sure it would be much colder than that. In 1992, a woman sued McDonald's for serving coffee at a temperature of 180. There's a lot of information here, but if you read it, we need to figure out how long should we wait to get to 155 degrees. So set y2 equal to 155. And then hit graph again. And you see a new intersection. Okay, So if you go close to that intersection, it's going to be around there, but we can actually calculate this. So second, and get to your calc, and we're going to go to intersect. Again, on mine it says left boundary, so I need to go to the left of the intersection, and then right boundary to the right of the intersection, and it gives us x equals, so after we calculate the intersect, we get x is equal to 8.5. So that means after 9 minutes, the coffee will be good to go. Okay, one more example here. Corleen invested money in a GIC. The value of her investment for the first 3 years is shown in the table. Write an exponential function that Corleen could use to predict the future value of her investment. So here we've got L1, time, and L2 is the value, so we got to go to stat. Now if you notice, there's a whole bunch of information here, and you could go all the way through and delete all of it, or we can just hit clear, oops, or clear list, and then we want to clear our L1 and our L2 list. So that's a quick way to do it, and now they're cleared. So L1, we've got 0, 1, 2, 3. If you forget how to do that, you can just individually delete stuff. It'll still work. So we start with 1,000, then we get 1,020, and we get 1,040.40, don't forget about that. And then we get 1,061.21. Okay, stat calc, exp, reg. Again, it doesn't seem to like to do it on the first go around here. Hopefully the second time. Okay, there we go, L1, L2, and we're going to store this as y1. Hit enter, and there's our equation. And that does not seem right. What happened here? Better check our lists. 0, 1, 2, 3. Oh, I see it. Do you see it? That's only 161.21. That should be 1,061.21. Let me just quit. How did I know that it was wrong? Well, if I look at the A value, I've got an A value of 1,457. Well, that's way higher than the initial value of the investment. So it can't be that high because that's the starting point. The A value tells you your initial value. So that's what clued me into that. So if I go back here, that appears to be better now. So if I go to stat and calc, see if it does it the first time around here. Yeah, it just doesn't like it the first one. You have to do it twice in a row. There we go. L1, L2, we're going to store this as y1. Hit enter, and that's a better equation there. So y is equal to 1,000 multiplied by 1.02 to the x. Explain what the numerical values mean. Well, 1,000 is the initial value of the investment. Okay, that's your A value. And 1.02 is the interest rate, your B value. But it's not 102% interest, it's a 2% increase. Okay, we're getting 2%. And then our X coordinate here represents time, or the number of years. So if Corleen invested a GIC that paid 1.4% compounded annually, how would this affect the value of the investment over time? It would still increase, just not by as much. 1.4 is less than a 2%. If Corleen invested a GIC that paid 1.4% compounded annually, how would it affect the function found in part A? Well, your new function would be 1,000 multiplied by 1.014 to the x, okay? Your B value would change. Okay, hopefully that helps with the calculator stuff, and we'll do some more examples in class.